Hello and welcome to Scholarph. This is one of our JAMB or UTME prep series, and in this recording we'll be taking the Chemistry 2010, the Type A. If you're new to the channel, be sure to subscribe to our channel to keep receiving awesome content, and like and share our videos. Okay, so in this recording, the major topics that are featured in this year, the fundamentals of chemistry, so things like atoms, elements, compounds, molecules. Also, you have mixtures, you have descriptive chemistry like metals and its compound, non-metals and its compounds. You have electrolysis, or let's say electrochemistry. You have questions on solubility. You have questions on the periodic table and the electronic configuration of elements. You also have questions on nuclear chemistry. Okay, questions on nuclear fission or nuclear fission. You also have questions on organic chemistry like diapack nomenclature and identifying the use of some of the compounds. Okay, before we begin, it is worth mentioning that in this recording we will be providing straight up or detailed answer depending on the question. So while some questions will require analysis, others are just more like filling the blanks. Okay, time is also one thing that you don't have in abundance in this UTM exam, and so you've got to learn how to save it, and you have to be time conscious. Okay, so we will be saving a lot of time. Also, calculators, yes, they are great and fast, but punching it takes off some time. And so in this recording, we will greatly reduce the use of calculators only to when it is necessary. So by learning some tips and some techniques, you can calculate or do calculations, do sums without the use of the calculator. Also, we've provided extra notes on the question and all the solutions, so you can read those notes up as well. Finally, you would also learn to interpret and analyze questions correctly, which is the first step to picking the correct answer. Okay, so let us get started. Okay, so first question is on the paper type that you're given. So you have which chemistry paper type is given to you: type A, type B, type C, or type D. Okay, so this question is very essential as it determines how your exam will be marked. Okay, so you'll be given different types. It could be type A, B, C, D. Sometimes it could be colors like type red, type yellow, type green. You must endeavor to pick the type that corresponds to what you're given. Okay, so for this recording, we're using the type A. Now, picking the wrong type, okay, is going to affect how your exam will be marked. That means that your papers or your answers will be marked with answers that are meant for another type. And so that will really mar your results. The next question is on mixtures. Which of the following is an example of a mixture? You have common salt, blood, sand, and washing soda. Okay, so mixtures, they are a mix of smaller or simpler substances, which could be atoms, they could be compounds or molecules. Now, like compounds, the particles of a mixture, they are physically combined, and so they can also be separated by physical means. Now, from the options here, the correct option is option B, which is blood. Blood is, a mixture. Okay, the common salt, that's the sodium chloride, is a compound. Sand is also a compound. It's actually silica, but industrially, sand is commercially a mixture. Okay, it contains silica, some calcite, and some organic deposits. All right, but blood here is correct to sand. The washing soda, that is your sodium triiosocarbonate, that is a compound. Okay, this is a question that requires some calculation. It's a question on atom, elements, and compound. Calculate the percentage by mass of nitrogen in calcium triosonitrate. A 8.5%, B 13.1%, C 17.1%, and D 27.6%. Okay, so the first thing that we need to do here is write the chemical formula for calcium triosonitrate 5, which is the CaNO3 and then 2. Next, we look for the molar mass of the compound. And how do we look for the molar mass? So in this compound, you have 1 calcium plus 2 of NO3. All right, 2 of NO3. So you have 2 in bracket N plus 3 molecules of oxygen. So that's 3O. Then each of we look at the atomic mass of each of the elements, each of the atoms that you have here. So calcium is 40, nitrogen is 14, 0 is oxygen is 16. So you have calcium as 40 plus 2 in brackets, nitrogen is 14 plus 3 times 0, oxygen, that's 16. All right, so you have 40 plus in bracket 2 in bracket 14 plus 3 times 6, 16 is 48. Then you have this to be equal to 40 plus this is 62. 2 times 62, that's 124. 40 plus 124, that's 164. All right, so now we have the molar mass of the compound. The next thing that we do is find the mass of nitrogen that you have in the compound. You have only 2 nitrogen in the compound. That is this 2 here multiplied by the nitrogen here. You have 2 nitrogen in the compound, and that will be equal to 2 times the atomic mass of nitrogen, which is 14, and that is 28. Next, we then find the percentage by mass of nitrogen in the compound, and that will be the mass of the nitrogen that you have in the compound, which you have calculated here to be 28, divided by 164, which is the molar mass of the compound, multiplied by 100%, and this will give you 17.0732%. You could use your calculator for something like this because you're going to be having like a decimal that is not, recurring. Then you can approximate this. Approximately, this is 17.1%, and that makes C the correct option. The next question relates to matter and the kinetic theory of energy and phase change. The droplets of water that are observed around a bottle of milk taken out of the refrigerator is due to the fact that so if you bring out like a bottle of milk from like a bottle basically from the refrigerator, you find some droplets of water forming on it. Okay, that's when you like leave it for some time. So it is due to A, water vapor in the air around the bottle gains some energy from the bottle. B, temperature of the milk drop as it loses heat into the environment, into the surroundings. And C, saturated vapor pressure of the milk is equal to the atmospheric pressure. And D, water vapor in the air around the bottle loses some of its energy to the bottle. Okay, so here's what happened. The water vapor that is around the bottle, okay, is at a greater temperature, right? Because it's in a gaseous form, right? So it's at a greater temperature. Now what happens is it loses some of its heat. It loses it to the bottle. Okay, it is transferred from an hot body to a colder body. So it loses some of its heat to the bottle, and the surrounding vapor then condenses. Okay, so when it loses its heat, then it's kind of like its energy reduces in a way. So it goes from that gaseous form that it is, that vapor that it is, it goes down to like the liquid. So that liquid is now seen, forming on the surface of the bottle. Okay, so the correct option here is option D, that the water vapor that is in the air around the bottle loses some of its kinetic energy to the bottle, and so it condenses into liquid. Okay, so here we have a question on gas laws. The volume of a given gas is V centimeter cube. What is the new volume of the gas if the pressure is reduced to half at constant temperature? Okay, so we have A 4V centimeter cube, B 2V centimeter cube, C V over 2 centimeter cube, and D V centimeter cube. Okay, so this is a question that relates more to the Boyle's law, alright, talking about the relationship between the volume and the pressure. Now, by Boyle's law, pressure and volume are inversely proportional for an ideal gas, okay, at constant temperature. The pressure varies inversely as the volume. Now, what that means, what that implies, is that an increase in one will bring about a proportionate decrease in the other, and vice versa. That means that if the pressure increases, the volume decreases proportionately, and if the pressure decreases, the volume increases proportionately. So if, okay, as the question is saying, if the pressure is halved, so if the pressure is halved, that means the volume is going to double. Okay, so since it is inversely proportional, so that makes option B the correct option here. Okay, so this is a question on periodic table and electronic configuration. Moving from left to right across the period, the general rise in the first ionization energy can be attributed to the A, decrease in nuclear charge, B, increase in nuclear charge, C, decrease in screening effect, and D, increase in screening effect. Okay, so when you move across a period, when you go from left to right, that means you're moving from group 1, 2, 3 like that to group 8. Now what happens here is the ionization energy increases. Okay, it increases. The ionization energy here is the energy that is required to remove a loosely bonded electron from the outermost shell of an atom that is in its gaseous form. Now the rise in the ionization energy across the period is due to an increase in the nuclear charge, meaning that in the nucleus you have the protons that are positively charged and you have the electrons on the shell. Okay, now going by the general principle of electrostatics, there are unlike charges, they attract. So the proton and the electron, they are attracting. Now as you go from as you move like from left to right across the period, the number of proton and the number of electron is increasing, and so the number of attraction between them is like the level of attraction between them is also increasing, and so it becomes more difficult to remove an electron, and so that makes option B the correct answer, increase in nuclear charge. This question is also related to the periodic table and the electronic configuration. How many unpaired electrons are there in the nitrogen sub levels? A, you have 3, B, you have 2, C, you have 1, and D, you have none. That's like 0. Okay, so there are actually 3 unpaired electrons in the p subshell of nitrogen. Now if you write the electronic configuration of nitrogen, that is 1s2, 2s2, and 2p3. Okay, and this is the representation. So here you have the first, like the 1s2, the 2s2, and here you have the 2p3. Now in each orbital you're supposed to have 2 electrons that are paired, and as you can see in these p orbitals we have 3 unpaired electrons. This is also a question of periodic table and electronic configuration of elements. The stability of the noble gases is due to the fact that they A have no electrons in the outermost shell, B have duplet or octet electronic configurations, C belong to group 0 of the periodic table, and D they are volatile in nature. Okay, so all the noble gas, we also call them the rare gas, they also called the inert gas. Okay, they have the octet structure, meaning that they have 8 electrons in the outermost shell, except for helium, which has a duplet configuration with 2 electrons in its outermost shell. So that makes option B the correct option. This is yet another question on periodic table and electronic configuration. The maximum number of electrons in the L shell of an atom is, we have A2, B8, C18, and D32. Okay, so the maximum number of electrons in the KLML shell is 2, 8, 18, and 32 respectively. So in the K shell it is 2, in the L shell it is 8, M it is 18, N it is 32. Now the formula is gotten by 2n squared, okay, where n is 1 for the K shell, it is 2 for the L shell, it is 3 for the M shell, it is 4 for the N shell. You also have the O shell as well. Okay, so if you want to find the number of like the maximum number of electrons that you can have in any of this shell, it's simply substituting the value of n. So if for example the maximum number of electrons that you can have in M shell, so M is 3, so if you substitute that here, you're having 2n squared, that is 2 times n squared. Okay, and that is 2 times, like n is 3 for M, so you have 2 times 3 squared, that is 2 times 9, and that is 18. That's for M shell. So for L shell it is 8. Okay, that's with n as 2. So that makes B the correct option. Okay, this is a question on the periodic table and electronic configuration. Elements in the same period in the periodic table have the same. We have A, number of shells, B, atomic number, C, chemical properties, and D, physical properties. Okay, so elements in the same period, they have the same number of shells. For example, this is magnesium. All right, if you count the number of shells, the shells are what you have here. This 1, you have 2, and then you have 3. All right, so this magnesium has 3 shells. That means it belongs to period 3. All right, so that makes A the correct option. Now the next thing is the group of the element is determined by the number of valence electron that it has. That is the electron in the outermost shell. The outermost shell here is this one here, the outermost shell. All right, if you count the number of electrons on it, you have just 1 and you have 2. All right, so you have like 2 electrons there. So that means that magnesium belongs to group 2. All right, so magnesium belongs to period 3. That's going by the number of shells that it has, 1, 2, and 3, and then belongs to group 2, going by the number of valence electrons that it has, 1 and 2. All right, another thing, so let's say you have an element with this configuration here, 2, 8, 8, 2. All right, how do you determine the period of this element? It's simply by counting the number of shells. Each of this number is a shell, like the number of electrons on a shell. So you have 1, 2, 3, and 4. So this element belongs to group like period 4. All right, while to determine the group, you look at the number of electrons that it has in the outermost shell. That's the last number that you have, which here is 2. So this element, I can tell you that it belongs to period 4 of the periodic table and group 2. All right, another thing that we can also do with this configuration is find the atomic number of that element. And how do you do that? It is simply by adding up all of these numbers. So when you add up these numbers, you have 2 plus 8, that is 10, plus 8, 18, plus 2, that is 20. All right, so this atom has an atomic number of 20. All right, and so this of course is calcium. One other thing that I would like to mention is that elements that have the same number of valence electrons, they have a similar chemical property. Okay, this is a question on nuclear chemistry. The reaction above illustrates A, alpha decay, B, artificial transmutation, C, nuclear fusion, and D, nuclear fission. Okay, so there are 2 types of nuclear reaction. We have nuclear fission and we have nuclear fusion. In nuclear fission, an heavy nucleus splits into lighter nuclei, while in nuclear fission you have lighter nuclei combining to form an heavier nuclei. Okay, so if you look at this reaction here, you have deuterium. This is a radioisotope of hydrogen. You have it combining with tritium to form helium, which is an heavier nuclei. Okay, so here what we have is nuclear fusion. That's option C. That is lighter nuclei combining to form an heavier nuclei. Today's question is on non-metals and their compounds. It's also related to air and descriptive chemistry. Basically, a noble gas with a high power of fog penetration that is used in aerodrome beacons is A. Krypton, B. Argon, C. Helium, and D. Neon. Alright, so all of the options here they are noble gases, or what we call rare gases. Now, noble gases they are the least abundant gases in the atmosphere. Now, the neon light is used in aerodrome because of its high fog penetration. Okay, noble gases usually they use them in lighting. So for example, you have neon used in neon lighting. You have krypton in flash photography. Helium is used in filling balloons. It's also used as a shield in welding and also in fueling rockets. So the correct option here is option D. Okay, neon has a high power of fog penetration, and so it is used in aerodrome beacons. Okay, the next question is on water. Permanent hardness of water can be removed by A. Filtration, B. Adding slacked lime, C. Adding caustic soda, and D. By boiling. Okay, so there are two types of hardness of water. There is temporary hardness of water and there is permanent hardness of water. Okay, hardness of water generally is due to the presence of calcium and magnesium ions in form of triazocarbonate or tetraoxosulfate. Now, the temporary hardness is due to the presence of calcium bicarbonate or calcium hydrogen triazocarbonate or magnesium hydrogen triazocarbonate, and it can simply be removed by boiling or by the addition of calculated amount of slacked lime. Okay, however, this is not the case here, because we are dealing with permanent hardness of water. Now, permanent hardness of water is due to the presence of calcium ion and magnesium ion in form of tetraoxosulfate, and this can be removed by the addition of zeolite, by the lime soda process, or by the use of washing soda and caustic soda. That's the sodium hydroxide. So that makes option C here correct. Okay. Okay, next, this is the question on substances, fundamental chemistry, basically, fundamentals of chemistry. Substances employed as drying agents are usually A. amphoteric, B. hygroscopic, C. efflorescent, and D. acidic. Okay, so hygroscopic substances, they also called humectants, and they are substances that are able to absorb moistures. Okay, and so they are used as drying agents. Examples include your calcium oxide, your sodium triazonitrate, and your copper oxide. So you have option B as the correct option here, hygroscopic. Okay, next is a question on solubility. It says calculate the solubility in mole per dm cube of 40 grams of copper tetraoxosulfate dissolved in 100 grams of water at 120 degrees Celsius. We have A 4.00, B 2.50, C 0.40, and D 0.25. Okay, so there are many formulae that we have for solubility. All right, about 3 of them, depending on the question itself. All right, solubility in moles per dm cube is given as the number of moles of the substance times 1000 over the volume or the mass of water in which the substance was dissolved. If it is in gram per mole per dm cube, then it is given as mass times 1000 divided by volume or mass of water. While the solubility per a given gram of water, like x gram of water, is given as solubility equals number of moles times x over the volume or mass. So for this question, we are using the first formula. All right, so we are looking for the number of moles of the substance. We have been given the volume already, all right, or the mass of the water, which is of course 100 gram here. So what we need to do is find the number of moles of the substance and then use this formula. And so to find the number of moles of the substance, first we need to find the molar mass of the compound itself, which is your copper tetraoxosulfate. That is Cu plus sulfur plus 4 molecules of oxygen. So you have copper 64, sulfur 32, oxygen 16, 4 times 16, that is 64. 64 plus 64, that is 128 plus 32. You have 160 gram. That is the molar mass of the compound. Then we look at the given mass of the compound, which from the question is 40. Okay, they said of 40 grams of copper sulfate. That is the given mass. The number of moles is then equal to the given mass of the compound divided by the molar mass of the compound. So you have 40 divided by 160, and that gives you 0.25. Now we have the number of moles. We can now use this formula here. All right, this first formula here. So you have solubility is equal to number of moles, which is 0.25 times 1000 over 100, which is like the mass of the water. So this then is this 100 in this is 10. So 0.25 times 10, that will be 2.5 or 2.50, and that makes B the correct option. Okay, this is a question on solution, colloids, and solubility. Coffee stains can best be removed by A. Kerosene, B. Turpentine, C. A solution of borax in water, and D. Ammonia solution. Okay, so all of these options are, of course, different solutions. You have kerosene, turpentine, solution of borax in water, and ammonia solution. However, coffee stain is removed with a solution of borax in water. Okay, that's option C. Turpentine is used in mixing waterproof paints, and they also use it in washing paint brushes. Okay, so after painting. While ethanol is used in making vulcanizer solution, okay, by dissolving the rubber and some other substance in it. It's also used in making iodine solution that is used in dressing wound. Ammonia and kerosene, they are used to remove fat, oil, and grease stains. Next question is on air and environmental pollution. Carbon 2 oxide, that's carbon monoxide, is considered dangerous if it is inhaled, mainly because it A. can cause injury to the nervous system, C. competes with oxygen in the blood, B. competes with oxygen in the blood, C. competes with carbon 4 oxide in the blood, that's carbon dioxide, and C. can cause lung cancer. Okay, carbon monoxide disturbs the action of the pigment hemoglobin. Now, the hemoglobin is a pigment, okay, that's associated with the blood that helps the blood to bind oxygen. Okay, it binds, oxygen to the blood. Okay, so when you have carbon monoxide inhaled, it disturbs the action of that pigment of hemoglobin. So it competes with oxygen in the blood. That's option B. This question is on acid, base, and salt. The acid that is used to remove rust, okay, is A. boric acid, B. hydrochloric acid, C. nitrate acid, and D. tetraoxosulfate 6 acid. Okay, hydrochloric acid and oxalic acid, they are used to remove rust. Okay, the boric acid is used in treating microbial infections. Okay, in treating infections that are caused by harmful pathogens. While nitric acid is used in producing fertilizers, that's a triazonitrate acid, and tetraoxosulfate 6 acid, that's H2SO4, is used as a drying agent. It is also used in car battery as an electrolyte. So next is a question on acid, base, and salt. It's also relating to stoichiometry. Calculate the volume of 0.5 moles per dm cube tetraoxosulfate 6 acid that is neutralized by 25 cm cube of 0.1 mole per dm cube sodium hydroxide. You have A 5.0 cm cube, B 2.5 cm cube, C 0.4 cm cube, and D 0.1 cm cube. Alright, so let's start by writing out the parameters that we are given. We are given the constitution of the acid as 0.5 moles per dm cube. This capital M here is the same thing as this in full, like mole per dm cube. The constitution of the base is 0.1. Alright, then the volume of the acid is what we are required to find. Calculate the volume of this, acid. Then the volume of the base we are given as 25 centimeter cube. Alright. Next, you recall the formula CAVA over CBVB equals NaNB. This is constitution of the acid, volume of the acid, constitution of the base, volume of the base, number of moles of the acid, number of moles of the base. Now you see here already of this from this 4 we have 3 already. What we are looking for is now VA. However, we don't have the number of moles of the acid and the number of moles of the base. And to get that, we will need to write the equation of the reaction for this H2SO4 and sodium hydroxide. So in this reaction, it's an acid-base reaction, so you expect that the acid will react with the base and produce, a salt and water. Now, if you look at this equation, you realize that the ratio of the number of moles of the acid, so that of the base is 1 to 2. All right, like the coefficient here is 1. All right, and here it is 2. for this base. So your Na we take it as 1 and your Nb we take it as 2, or the ratio. Then next we call the formula. All right, so we now substitute for what we have already. So your Ca is 0.5 times Va, which is what we're looking for. Cb is 0.1 times 25 equals the ratio of Na to Nb, that is 1 to 2. The next thing is we'll cross multiply. All right, so when you cross multiply this here like this, like multiply this here, you're going to be having 2 multiplied by 0.5 times Va equals, cross multiply this and you have 1 times 0.1 times 25. 2 times 0.5 is 1, so 1 times Va is just Va basically. Then 1 times 0.1, that's 0.1 times 25, and that is 2.5 centimeter cube. That makes B the correct option. This question relates to acid, base, and salt. The color of indicators in different medium. The color of methyl orange in alkaline medium is A yellow, B pink, C orange, and D red. Okay, so methyl orange is yellowish in an alkaline medium, it is reddish in an acidic medium, and orange in a neutral medium. So that makes option A the correct option. The next question is also on acid, base, and salt, and solubility. Which of the following salts is slightly soluble in water? You have A silver chloride, B calcium tetraoxosulfate, C sodium thiazocarbonate, and D lead chloride. Okay, so chlorides of silver and lead, they are insoluble in water. They are insoluble in water. However, lead chloride is soluble in hot water. Okay. Sodium thiazocarbonates of sodium are insoluble in water. Okay, thiazocarbonates are generally soluble in water. They are insoluble in water, except for those of lithium, sodium, potassium, ammonium, and uranium. Okay, calcium tetraoxosulfate is slightly soluble in water, and it is responsible for the permanent nausea of water. Okay, this is a question on oxidation and reduction reaction. In the above reaction, the reducing agent is A triazonitrate acid, B water H2O, C pH3, that's phosphine, and D silver nitrates. Okay, so first it should be noted that the reductant, that is the reducing agent, and the oxidants, they are located on the left side of the equation. They are always on the left side of the equation, that is on the reactant side of the equation. So we have no business here with the right side of this equation. Okay, so our answer is not coming from here, it is coming from here. Okay, so any of these three could be the answer. Now in this question, the phosphine, that's a pH3, is the reducing agent. As you can see, it undergoes oxidation, that is oxygen was added to it. It undergoes what? Oxidation. So that makes option C the correct option. Next question is on naming. The IUPAC nomenclature of the compound LiAlH4 is, so you have lithium tetrahydroaluminate 3, you have B aluminium tetrahydrolithium, and C tetrahydrolithium aluminate, and D you have lithium aluminium hydride. Okay, so option A is the correct option. It is lithium tetrahydroaluminate. Okay, this is a question on metals and their compounds. Iron can be protected from corrosion, that is from rusting, by coating the surface with option A, you have gold, B silver, C copper, and D zinc. Okay, so the correct option here is option D, that is zinc. Okay, galvanization is a process by which iron is coated with zinc, and the purpose is to prevent the iron from corrosion. Another substance that could be used instead of the zinc is cadmium. However, the zinc is more available and it's cheaper. Okay, the next question is on electrochemistry, electrolysis specifically. What quantity of aluminum is deposited when a current of 10 ampere is passed through a solution of aluminum for 1930 seconds? A 0.2 grams, B 1.8 grams, C 5.4 grams, and D 14.2 grams. Okay, just a brief introduction. So from far this first law of electrolysis, we have it that the mass of the element that is deposited is directly proportional to the quantity of electricity. So from here you have M is equal to Q multiplied by, a constant, that's your Z, which Z there is the what we call the electrochemical equivalent of the substance. So you have M is equal to Q times Z, that is ZQ. But Q here, the quantity of electricity, is equal to current times time. So you have M to be equal to ZIT, that's substituting IT for Q. Okay. Now, for aluminium, which has an oxidation number of 3, okay, the quantity of electricity that will be required is 3 Faraday. Okay, that is to liberate 1 mole of aluminium, which is 25 grams of aluminium. Okay, that's the atomic mass of aluminium. So 1 mole of aluminium is 25 grams. So to liberate 1 mole of it, we are going to need 3 Faraday of electricity. So 27 grams of aluminium will require 3 Faraday of electricity, and 1 Faraday is 96,500 coulombs. So 3 Faraday, that's 3 times 96,500 coulomb. Okay, now what quantity of aluminium is deposited? Let that quantity be X. So we say X quantity of aluminium is deposited with, let's say, Q equals IT, where this I is, Q here, your I here is the quantity of electricity that you are given, 10 ampere, and this is the time, okay, under which the whole process ran. So you have 10 times 1930, and this is like 19,300. Okay, so 27 grams of aluminium would require 3 Faraday of electricity, while X gram, what we are doing here is we're looking for X. Okay, X gram, 19,300 coulombs of electricity will produce X gram. So we're looking for that X here. So what we'll do is set up a relation. Okay, so you have 27 over X equals this, that's 3 times 96,500 over what you have here, which is 19,300. Okay, so 3 times 96,500, that is 289,500. So for something like this, you could just use your calculator. All right, next is we cross multiply. Okay, so when you cross multiply, you're going to be having 27 times this. Okay, that's 9,300, and all of this times X. Okay, so then you can rewrite this, just bringing X to the left side like this, nothing changes, it's just the same thing, it's just rewriting the equation. Okay, so then we have this, so 27 times 19,300, that is 521,100. So to get the value of our X here, we divide both sides by the coefficient of X, and so, which is of course 289,500. So you have X to be equal to 1.8 gram. That is 521,100 divided by 289,500. So you have option B, 1.8 gram, as the correct option. Okay, this question is on electrochemistry and chemical equilibria. In which of the following is the entropy change positive? A, thermal dissociation of ammonium chloride. B, the reaction between an acid and a base. C, the addition of concentrated acid to water. And D, the dissolution of sodium metal in water. Okay, so entropy is the measure of the degree of randomness or disorderliness of a system. Okay, an increase in temperature would bring about an increase in the entropy of a system. That makes option A, thermal dissociation of ammonium chloride. That's the correct option, because that requires that the ammonium chloride be heated, and when that happens, the entropy of that system is going to increase. Okay, because there's going to be like an increased randomness or agitation of the particles, the reacting particles there, which is the ammonium chloride. Okay, so here's a question on chemical equilibrium. If a reaction is exothermic and there is a great disorder, it means that A, the reaction is static. B, it is in a state of equilibrium. C, there's a large increase. There will be a large increase in free energy. And D, there will be a large decrease in free energy. Okay, so the Gibbs free energy is given as delta G, that's the Gibbs free energy, equals delta H, which is your enthalpy change, plus T, the temperature, and delta S, which is the entropy. Okay, now where your delta H is negative, okay, and delta H is negative here because the reaction is exothermic. So in an exothermic reaction, delta H is negative, while in an endothermic reaction, it is positive. Now, if delta H is negative, okay, and your delta S, your entropy change, is large, okay, there's a great disorder, meaning there's a great entropy, okay, then that means that your delta G would be like there'll be an increase in the free energy, because by the time you look at the difference between, like, when you subtract this is negative because the reaction is exothermic. When you subtract it from this, okay, you'll be having something positive. Okay, so that means the delta G larger, so there'll be an increase in the free energy. That makes option C the correct option here. Next is a question on nonmetals and their compounds. In the preparation of oxygen by heating potassium thiazochlorate in the presence of manganese oxide, only moderate heat is required because is needed because the catalyst acts by A. lowering the pressure of the reaction, B. increasing the surface area of the reactant, C. increasing the rate of the reaction, and D. lowering the energy barrier of the reaction. So generally, catalysts, they help to lower the energy barrier or the activation energy of a reaction. Okay, the activation energy is the minimum energy that is required for a reaction to occur. So the use of a catalyst is going to lower the activation energy, allowing for that reaction to proceed, okay, with lesser energy input. So that makes option D the correct option here. Alright, next is a question on chemical equilibria. The graph above demonstrates the effects of A. surface area on the rate of reaction, B. catalyst on the rate of reaction, C. pressure on the rate of reaction, concentration on the rate of reaction. That's option D. Alright, so this graph here demonstrates the effect of surface area on the rate of reaction. Basically, the greater the exposed surface area that is active in the reaction, the faster the rate of the reaction. Alright, and that is why reaction is faster with powdered solid than with chips and in lumps, because in a powdered solid more of the surface are exposed, all right, to reaction, and basically also the mass of the reacting particles is like reduced in it. And that's why if you look at this this diagram here, you realize that the reaction with powdered marble came to like the end point under a lesser time interval than with a chip. Let's say we had a lump, for example, now that isn't like bigger than this chip, then that may even extend to something like here. All right, it will take even a longer time. All right, so this graph here demonstrates the effect of surface area on the rate of reaction. We have yet another question on chemical equilibrium. So we have an equation here. What happens to the equilibrium constant of the reaction above if the temperature is increased? A. It is unaffected. B. It becomes 0. C. It decreases. And D. It increases. Okay, so this is a thermochemical reaction where it is lost to the environment. Now, the equilibrium constant increases when the forward reaction is favored, while it decreases when the backward reaction is favored. Now, for an exothermic reaction, your delta H, the enthalpy change, is negative. Now, increasing the temperature here is going to favor the backward reaction. Okay, so that would reduce the equilibrium constant. So that makes C the correct option. If delta H here was to be like positive, as is the case with endothermic reaction, increasing the temperature is going to favor the forward reaction, and so the equilibrium constant of the reaction is going to increase. Okay, this is a question on nonmetals and their compound. So a solution of an unknown compound, a little dilute tetraoxosulfate 6 acid, was added with some freshly prepared iron 2 tetraoxosulfate 6 solution. The brown ring observed after the addition of a stream of conc tetraoxosulfate 6 confirms the presence of A. CO, B. Cl chloride ion, and C. SO, and D. NO. That's nitrate ion. Okay, so the brown ring test is used to indicate or test for the presence of nitrate ion. That is option D. Okay, so the test is performed by adding tetraoxosulfate 6 acid to a triazonitrate. Okay, it is added to a triazonitrate. So the unknown compound here in the question is a triazonitrate. So iron 2 sulfate is added to a triazonitrate, then it is followed by the addition of conc tetraoxosulfate 6 acid. Okay, concentrated tetraoxosulfate 6 acid. Now the resulting solution is going to be of 3 layers. Okay, the middle layer is that containing the nitrate ion, like the middle layer that appears as a brown ring is that layer where you have the nitrate ion. This is a question on non-metals and their compound. In the diagram above, the gas produced is nitric oxide, nitrogen dioxide, dinitrogen oxide, or dinitrogen tetroxide. Okay, so in the diagram we have copper turnings reacting with dilute nitrates. Okay, and the reaction between copper turnings and dilute nitrates will generate the nitric oxide. That's NO. That's option A. However, if it is with conc nitrate, then nitrogen dioxide will be generated instead. Okay, this is a question on acid, base, and salt. Which of the following is used in rocket fuels? A. HNO3, that's triosonitrate 5 acid. You have ethanoic acid, you have tetraoxosulfate 6 acid, and you have hydrochloric acid. The correct option here is A. Okay, triosonitrate acid is the main component of the red fuming nitric acid, which contains 84% of the triosonitrate acid, 13% of the nitrogen oxide, and about 1 to 2% of water. Okay, the red fuming nitric acid is used as a work propellant or fuel. Okay, says in the diagram above, the purpose of the asbestos is to A. Absorb impurities, B. Catalyze the reaction, C. Solidify the gas, and D. To dry the gas. So this is a question relating to non-metals and their compound. B is the correct option. The platinized asbestos acts as a catalyst in the production of sulfur 6 oxide from the further oxidation of sulfur 4 oxide. Next is a question on mixtures, metals, and their compounds. A constituent that is common to both bronze and solder is A. Lead, B. Silver, C. Copper, and D. Tin. So the bronze and solder, they are alloys, both containing tin. The bronze is an alloy of tin and zinc, while the solder is an alloy of tin and lead. So that makes option D the correct option. Next is yet another question on metals and their compounds. When iron is exposed to moist air, it gradually rusts. This is due to the formation of A. Hydrated iron 3 oxide, B. Anhydrous iron 3 oxide, C. Anhydrous iron 2 oxide, and D. Hydrated iron 2 oxide. So hydrated iron 3 oxide is rust. That's option A. So iron rust due to the formation of hydrated iron 3 oxide from the oxidation of the iron. Now rusting requires moisture, that is a mixture of water and oxygen. Okay, so to prevent the rusting of iron, it could be galvanized with zinc, or it could be electroplated with cadmium. Also, hydrochloric acid and oxalic acid are used to remove iron rust. And I think this is past. We've talked about in a previous question, we've talked about galvanization and about the removal of rust. Okay, this is a question on metals and their compounds. It's also related to qualitative analysis. A compound gives an orange-red color to non-luminous flame. This compound is likely to contain sodium ion, calcium ion, iron 3, or iron 2. Okay, so the production of orange-red color with non-luminous flame indicates the presence of calcium ion. That's option B. This is a question on substances. It's also related to metals. Stainless steel is used for making A. Magnets, B. Tools, C. Coins and medals, D. The moving parts of clocks. Okay, so stainless steel is used in making permanent magnets. The steel is an alloy of iron and carbon. The stainless steel is an alloy of iron, chromium, nickel, and some carbon. Next is a question on organic chemistry. The residual solids from the fractional distillation of petroleum are used as A. Coatings for pipe, B. Raw materials for the cracking process, C. Fuel for driving tractors, and D. Fuel for jet engines. B. They are used as raw materials for the cracking process. All right, this is a question on hyperchemical nomenclature relating to organic chemistry. The hyperchemical nomenclature of the compound above, this compound here, is A 4-ethyl octane, B 5-ethyl octane, C 5-propyl heptane, and D 3-propyl heptane. Okay, the first thing that we need to do is locate the longest carbon atom here. All right, that determines the parent, compound. Now, if you read the carbon atoms like this, you're going to be having 1, then 2, 3, 4. That is with this 3 here. All right, then 5, 6, 7. So it's 7 this way. If you read it like this, all right, like this, then you're going to be having 1, 2, 3, 4, 5, 6. That's 6. If you read it this way, you'll be having 1, 3, that is 4, then 5, 6, 7, 8. So this gives you the longest carbon chain. So 8 here, that is oct. All right, that is oct. Then that means that we now treat this one here, this C2H5, we are going to treat it as what we call a substituent. All right, a substituent, meaning it was actually an hydrogen that was replaced with this. Now this formula that I have here, I can write it this way. What I've simply done is bring this to the top here and bring this here. Do you get the point here? I'm bringing this here as a substituent, as it is here, and then I'm bringing this one to the side here. Then I can further write it this way. This is condensed here. This is actually 3CH2, so I can just expand it. I say 1, 2, 3. All right. Now if you look at all of this chain, it has only single bond. That makes it an alkane. So that means this is going to be like octane. Then the next thing is now our substituent here. This substituent, this C2H5, which is ethyl. How do we locate it? All right, if you read from this left here, you're going to be having 1, 2, 3, 4, 5. So it's on like the 5th carbon atom going from the left. From the right, you have 1, 2, 3, 4. That's on the 4th carbon atom. We take the lesser count, which is from the right, and that is 4. So this will become 4-ethyl octane. 4-ethyl, that is, this ethyl is on the 4th carbon atom. All right, that's like the smaller count. All right, then ethyl, because this is ethyl, C2H5 is ethyl. All right, and octane, because we have like 8 carbon atom in the parent compound. All right, so this is 4-ethyl octane, and that is option A. Organic chemistry. Which of the following is used as fuel in miner's lamp? You have A ethanol, B ethane, C ethane, and D ethane. Ethane, also known as acetylene, is used as a fuel in the miner's lamp, okay, and in acetylene torch. And this is so to prevent explosion in the mines due to the presence of flammable gases like methane. So B is the correct option here. Organic chemistry. Which of the following organic compounds is very soluble in water? A ethanoic acid, B ethane, C ethene, and D we have propyl ethanoate. Okay, ethanoic acid is the most soluble. Okay, it's very soluble in water. Ethane is sparingly soluble in water. C2H4, that is ethane, it is insoluble in water, while esters, alkanoates, they are slightly soluble in water. So the most soluble here from the option is ethanoic acid, and that is option A. Benzene reacts with hydrogen in the presence of nickel catalyst at 18 degrees Celsius to give A xylene, B toluene, C cyclopentane, and D cyclohexane. Okay, so benzene can be hydrogenated under high temperature at about 18 degrees Celsius and pressure in the presence of catalyst to form cyclohexane. That's D. Next, which of the following is used to hasten the ripening of fruits? A ethane, B ethanol, C ethane, and D ethane. Ethane is used in the ripening of fruit. It is also called the ripening hormone in plants. Next, the final product of the reaction between methane and chlorine in the presence of ultraviolet light are hydrogen chloride and A trichloromethane, B dichloromethane, C tetrachloromethane, and D chloromethane. Okay, so when methane undergoes substitution reaction with chlorine, forming chloromethane, that is the first product. followed by dichloromethane, and then trichloromethane, and finally tetrachloromethane. Okay, that's option C. The reaction is it's photochemical, that is catalyzed by light. Then trichloromethane and tetrachloromethane, they are used in laundry and also in fire extinguishers. Next, the correct order of increasing boiling point of the following compounds: we have propanol, we have heptane, and we have butane. Is we have option A, B, C, and D. Okay, so the boiling point of alkanes increases down the group. Lighter alkanes like your butane would have a lower boiling point compared to heptane. Okay, while alkanols with the OH group, they have a relatively high boiling point due to the nature of their intermolecular force, and their volatility decreases down the group. And so that means the one with the least boiling point is going to be your butane, that's C4H10, then followed by your C7H6, and finally the alkanol. So that makes option B the correct option. Okay, one of the major uses of alkane is A, as domestic and industrial fuel, B, in the hydrogenation of oils, C, in the textile industries, and D, in the production of plastics. So alkanes have numerous uses. They are used as fuels, they are used as solvents for the hydrogenation of fat, they are used as anticorrosive agents, etc. However, the bulk of the alkane goes into the use as domestic or industrial fuel. That makes A the correct option. The alkanes used in dry cleaning industries are A, trichloromethane and tetrachloromethane, B, chloroethane and dichloroethane, C, trichloroethane and tetrachloroethane, and D, chloroethane and dichloroethane. Okay, so trichloromethane and tetrachloromethane, they are used in laundry. They are used as cleaning agents in laundries. They are also used in fire extinguishers. Okay, two hydrocarbons X and Y are treated with bromine water. X decolorizes the solution and Y did not. Which class of compound does Y belong? A, benzene, B, alkynes, C, alkanes, and D, alkanes. Okay, so the brownish bromine water is used to test for the saturation of an hydrocarbon. Saturated hydrocarbons like the alkanes have no effect. They did not affect any color change in the bromine water. Okay, the bromine water itself is brownish. All right. While unsaturated carbons like the alkanes and the alkynes, they would decolorize a bromine water due to an addition reaction. Okay, so that makes option D the correct option. Alkanes, they do not decolorize bromine water. So why? Since they did not decolorize the solution, it must have been an alkane. Finally, the last question. The compound that is used as an anesthetic is, you have A, tetrachloromethane, we have trichloromethane, we have dichloromethane, and we have chloromethane. Okay, trichloromethane or chloroform is used as an anesthetic during surgical operation to alleviate pains by reducing sensation. All right, so it is meant to reduce the pain that the patient is supposed to feel during the operation. Other anesthetics include your laughing gas, the nitrogen oxide, and methoxypropane. Okay, so it's a wrap on Chemistry 2010. If you're new to this channel, please endeavor to subscribe and turn the notification icon on, and like and share videos. Thank you for watching. Also, we have our playlist for our crash courses that you could take, which is specifically tailored for examination candidates and also for regular students. So if you're looking to get a hold of a topic, you want to get an overview of everything relating to something, just check out our playlists. We have the physics crash courses, chemistry and biology crash courses. All right, all the best in your examination, and don't forget, you can also visit exams.scholaf.com to practice UTME for free or take modular quizzes. So if you've studied the topic, you've read something, you can just head on to exams.scholaf.com and take a modular quiz and see, just test yourself and see how good you're doing with that topic. All right, thank you.